Welcome to episode 77 of Meet the GIMP. My name is Rolf Steinert and I'm recording this in Bremen, northern Germany. At the beginning of this show, I want to point you to a charity which is based in Oakland in California. I have lost the mail where I got this link here, but thank you for pointing me to this. And I want to present this here as an example for a lot of such organizations, and perhaps if you're in the IT business, you can think about supporting them in your decisions. What these guys are doing is basically they take computers, used up computers in businesses, and so a lot of businesses swap their computers every 2 or 3 years, and they take them, check them, repair them, get them ready again, and give them for schools and other organizations or private persons who need a computer and can't afford a big one or a new one. For example, my school in Hamburg, where I organized such a project, we had the money for 30 computers or 40 computers and no network, and we bought at a commercial firm refurbished computers which were good enough for school use, and well, we bought more than 100 and a complete network which we installed ourselves for the whole school. If you are in the IT business and have to get rid of a lot of computers, just contact such charities near you. And I think these guys here can point you, if you're in the US, can point you to sister organizations. But now to the GIMP. I will continue my exploration of this urban happy scene I had in the last episode, but after my eye operation I'm not that sure about the colors, because with my right eye I see the colors much more brightly and brilliantly than with my left eye. Well, the left eye lens has 51 years of use and tear and ultraviolet, which damages protein quite a lot, and the right one is brand new and made out of plastic. So just give me a little bit of time until I'm sure what I'm seeing. But I have stumbled about a strange thing which I thought I will never have a use for that, and that is the convolution matrix filter. And you find it through filters generic convolution matrix, and let's look for that here. I have, why is my image not coming with me here? I have an image here which I shot with my D200 and developed in UFRAW. In the UFRAW version I showed you last week. And by the way, if you are running into problems getting that version, have a look at Pascal's site. There he has the sources and the binaries for Ubuntu. If you are using another operating system, well, you have to look for yourself. I think on the website of UFRAW there are not that recent binaries, but perhaps you can make yourself familiar with compiling this stuff. You have to include the LensFun plugin for getting this here. This is now corrected for barrel distortion or cushion distortion, and then this UFRAW plugin comes up really great. So, convolution matrix, filters, generic, convolution matrix. Apply a generic, you can't see this, apply a generic 5x5 convolution matrix. And here you see, well, let me pull this up here. Here you see this matrix. let's just go here into the center. Well, let's go here to the light bulbs in this sign. This was a circus here in town, Circus Roncalli, and well, they had a nice box office. If we look around, the top looks basically like any GIMP filter, a preview. And then we have a horrible thing here looking like a lot of numbers and very mathematical. And here a border. What shall be done with a border? Extend, wrap, and we can work on different channels. This is easy, and here we'll see what happens. But this stuff here, okay, if you look here, we have a lot of zeros and in the center a 1, and as you see here in the image, nothing happens. Let's play around. Let's just enter here a 0, 2, black. Now let's try 2. You see, the image gets a lot brighter. And if I enter, let's say, 50, we get, wow, really harsh contrasts and very strange colors. Okay, perhaps we'll have to look up what this does. As usual, you find this here in docs.gimp.org, and then you'll have the help files there, and there it's the file en plugin conv matrix HTML, but it's much easier just to search in the table of contents. This sounds a bit like a warning here. Here is a mathematician's domain. Most of filters are using convolution matrix. With the convolution matrix filter, if the fancy takes you, you can build a custom filter. Well, this is a warning, and this is a promise. Most of the filters are using the convolution matrix, so this seems to be a very versatile tool. And let's look here. What's a convolution matrix? It's possible to get a raw idea of it without using mathematical tools. Oh, that's a good one. That only a few know. Convolution is a treatment of a matrix by another one, which is called kernel. Okay, so we take one matrix. A matrix is, well, a grid of numbers, and we take another matrix, a kernel, and hit the first matrix with the second one, with the kernel. So, the first matrix is the image to be treated. The image is a bidimensional collection of pixels in rectangular coordinates. Well, we knew that, didn't we? An image is a heap of pixels organized in rows and columns, and this is a bidimensional collection of pixels in rectangular coordinates. Okay, and the used kernel, this second matrix, depends on the effect you want. GIMP uses 5x5 or 3x3 matrices. We will consider only 3x3 matrices. They are the most used, and they are enough for all effects you want. If all border values of a kernel are set to 0, then the system will consider it as a 3x3 matrix. Okay, so this is the kernel. This is my image, the basic matrix, and that's the kernel. And if these numbers around here are 0, then GIMP considers only this inner part, which is then a 3x3 matrix. So with these numbers here, we hit this grid, and now we'll look what happens there. The filter studies successively every pixel of the image. For each of them, which we call the initial pixel, it multiplies the value of this pixel and the values of the 8 surrounding pixels by the kernel corresponding value. Then it adds the result, and the initial pixel is set with this final result value. Okay, so this convolution matrix filter goes through the whole image pixel by pixel. So let's have a look here at the example. These are the image values. This is one value of the three values that we have in an image, are G and B. Or does it work on, well, perhaps it works on the fourth value on opacity too. So this is one of these values, and this is the pixel we are just treating, and these are the surrounding pixels. And if you look here, we are here in an area where we have darker pixels above and on the left, and brighter pixels down and below. 0 is black and 255 is white, as long as we have 8-bit. So this is the kernel, and we slap this kernel on this matrix here. And what we have to do is multiply this with this. 40 by 0 is 0. 1 by 42 is 42, and so on. So you see here a lot of zeros. This comes out as 0, and then we add up a lot of zeros and 142, and we get 42 for the resulting image. And what has happened here, if you think this through from starting from here and going on, what happens is that you just pull this image down 1 pixel. So this whole stuff has just moved this image down 1 pixel. It works on a copy, so this 42 is in the copy, and when we are here with our filter, then there's the 50 and not the 42, which is in the new copy. Let's look at some examples. Sharpening. Oh, well, here's a warning. Design of kernels is based on high levels mathematics, or, as I say, on tinkering around a bit too. You can find ready-made kernels on the web. Here are a few examples. So, sharpening. This image here, it's used a lot in the GIMP manuals. This has been sharpened by applying this -1, -1, -1, -1, and 5. So let's try this. Just here a 5, and here -1, -1. You see here stuff happening. This has some I think this has some real value with experimenting with this stuff. Perhaps we get some. I think there are some nice possibilities here. So let's just look. This is without the preview, and this is with convolution matrix. You see here, this is definitely sharpened. I think this is now a bit over sharpened. But it's a step forward here. But if I switch these values to -0.5 and the center one to 3, then I get a nice sharpening. So this was out, and this was the convolution matrix on. So we can enter here decimal numbers, rational numbers, and this is good, really good for scripting, especially if you think that you don't have to sharpen all around. You can do something like this here. Well, this I've done now a little bit more of it. You see here a circle of -2 around the center, and then 17 in the middle. Well, 17, we have here 8 times -2 makes -16, and plus 17, 1 is the result of the matrix. And you see here, now we come into something like edge detection. We have here where this borders between light and dark are. Let me switch this off. There we have now a bright line. And with tinkering around here, let's simply make this 0 here. Now I have to subtract 11 here. I have to set this to 11. We can treat different directions of these contrast lines with different values, and this can no filter do. So this is no ready-made filter. This is a good thing if you have a special problem or if you just want to tinker around with some stuff. The first time I heard from the convolution matrix filter was with one thing about this old ink challenge I gave you. Oh, I have to show the results. And there this convolution matrix was used to emphasize strokes into a certain direction. So this is quite a nice tool. Let's have a look what we can do else. We had sharpen. Of course, we can blur. Here we get an image which is the result of the average of its surrounding pixels. All these 9 surrounding pixels here. Up to now I said the matrix should add up to 1. Well, here it is definitely 9. Let's have a look what happens when I do this to my image. And you see I have here a very pop-arty image, and I have to click here on normalize to get this matrix back. So normalize gets your matrix back to the value 1, and with normalize on you can enter values like you want, and you will keep the lightness of the image and change other stuff in the image. So we have cleared this here also. Of course, if we change these values here from 1 to other values, we can blur in a direction. We can well, we can make very funny things with blurring. Then there is edge enhance. Well, here we have 1 and -1. You see here the edges come out. Let's try this one. And really, we have got enhanced edges here. Let me switch off the preview. You see here, everywhere where a color ends, or an area ends, then we have here a line. And let's play a little bit around here. -1 here. Wow, this looks really nice. Let's have a look into the sky. The sky turns blue. This I tried this here as the final image. This looks really cool. What happens if I do this +1 here? Well, the image gets a little bit blurry. So -1 is better here. What happens when I go here and put a 2 here? Then I get an enhanced edge effect. Let's do here 0 and here -2. Well, also enhanced edge effect, and perhaps a little bit sharper. You can do a lot of stuff with this convolution matrix filter, and for example, here is also about edge detecting and embossing, and I think a lot of more stuff. So if you are in the need of doing something special to your image, or part of your image, to sharpen just a little bit of wire, or without getting it to the bricks or so, then perhaps you can think of this convolution matrix filter and try something with that. And with this I say goodbye up to next week. visit the forum at forum.meetthegimp.org and join one of the discussions there. Quite interesting stuff running there at the moment. And go to the blog at meetthegimp.org and leave a comment for this show. I have to say a big thank you to all the well wishes I got mail from or postings in the forum on the blog. I'm quite well with my eye now and can't wait for the final adjustment with laser beams and so on. Philip's show will be on this Thursday or next Thursday. We'll still have to figure that out. This is slowly coming back to normal. So, goodbye up to next Tuesday.
photocastnetwork.com, your photography resource in the potosphere. photocastnetwork.com